So let's talk a little bit about counting in binary, or specifically, we want to look at it in the context of making our truth tables. So our truth tables are always listed with rows in binary order, meaning that they're counting properly with regards to how binary is counted. So let's kind of start with a big example here. Let's say we've got a four variable truth table we want to have. So we're going to have A, B, C, D. Or this is a 4-bit function, right? It uses 4 inputs or 4 bits. And let's start counting here. So just like every number system, we start off with zeros, right? This is 0, 0, 0, 0. And just like every other number system, the next number is 1. So we start at 0 and we go to 1. And just like if I were to say, I'm going to give you that many dollars, that's $975. We know we've got these zeros before it, but they don't actually change the value, right? I could say, oh, my paycheck has 7,000 zeros on it, but it matters. It really matters where the zeros are at, and if they're before the non-zero numbers, then they don't add any value. So same thing applies in binary. If we want to display 1, we can say 0, 0, 0, 1. And now we want to count up to 2. So we want to basically increment this value by 1. We want to add 1 to it. But since we're dealing with binary, this 1 can't turn to a 2. In fact, it's got to roll over into the next place, which is the 2's place. So that means we've got 0, 0, 1, 0. And now we've got a nice spot that we can add 1 to that. 0, 0, 1, 1. And now we want to add 1 to this value. So we want to add 1 here, but this is going to cause it to roll over. So that's going to make it a 0. And we're going to roll over into this one. And we can't make this value any bigger, so that means it's also going to roll over. And then, of course, this stays as a 0. So there's actually a pattern here that you might want to, or might notice, right? We've got our least significant bit is flipping all the time, 0, 1, 0, 1, 0. And then our next to least significant bit is going 0, 0, 1, 1. And we can expect that pattern to stay where it's going to go 0, 0, 1, 1. And so not surprisingly, our most significant is going to change the least. It's just going to, well, it's a little misleading when I say change the least. It means the way we organize this, it's only going to flip once as we go down. So let's now just continue counting here. So the next one we've got is 0, 1, 0, 1. And then after that, we've got 0, 1, 1, 0, 0, 1, 1, 1. And then we roll over. So normally we would have this all in one kind of big column table, but since I'm a little out of room, I'm just gonna kind of keep going on the other side here. So we got A, B, C, and D, and so we're gonna note that this is gonna go and continue on here. So now we've got we add 1 to this, and it rolls over to 1, 0, 0, 0. So 1, 0, 0, 0. And we keep counting. And so interestingly, you should note that this little segment here is just going to repeat, right? So we're going to have 0, 0, 1, 0, 1, 0, 0, 1, 1, so on and so forth. So we're going to have 1, 0, 0, 1, 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0, and finally 1 1 1 1. So this is something that I highly recommend you kind of practice, learning how to count in binary and just noticing how things roll over and kind of memorizing this pattern and being able to go for any number of bits, right? So the other thing is knowing the numbers, the decimal number value for each of these rows. And so it's actually not super difficult because since we're counting in the proper order, that means in decimal we also count in the proper order. So this is a 0, this is 1, this is a 1 in our 2's place, so this is 2, then we've got 2 plus 1, so this is our 3, and so on and so forth. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So just quickly, you'll note that we have 4 inputs, and we've got let's see how I want to say this. Our number of rows equals 2 to the number of bits, right? So n is the number of bits. And also something interesting is our max row value equals, it doesn't equal 2 to the n because we start at 0. So really, what it really equals is 2 to the n minus 1, right? So that's this right there. Just some kind of things that you should know or expect